It is claimed by some flat earthers that a plane would not be able to land due to the difference in speeds around the Earth. So, 1,000 miles an hour at the equator compared to the poles, that a plane would not be able to get up to speed in order to land. The tangential speed of Earth's rotation at a point on the Earth can be approximated by multiplying the speed at the equator by the cosine of the latitude. So the tangential velocity at the equator is 24,901 miles in circumference divided by a sidereal day, which is 86,164 seconds, which gives us 0.28899540411. At 80 degree latitude, the tangential velocity equals the tangential velocity at the equator, which again is 0.28899540411, times the cosine of 80 degrees, which gives us 0.05018352527 miles per second. So if we times that by 60 seconds and we times that by 60 minutes, that gives us miles per hour, which equals 180.6606900972 miles per hour. It's basically 180 miles an hour. A plane travelling from 80 degree latitude with a speed of 500 miles per hour. 1 degree of Earth's curvature is 69 miles. 500 miles per hour divided by 69 miles is 7.2 degrees per hour. So the plane will travel 7.2 degrees per hour. At 80 degrees, the tangential velocity is 180 miles an hour. 80 degree latitude minus 7.2 degrees equals 72.8 degrees latitude. So a plane travelling 500 miles per hour will travel 7.2 degrees in 1 hour, and at 72.8 degrees, the tangential velocity is 307 miles per hour. 307 minus 180 equals 127 miles per hour difference between the tangential velocities at the latitude of 80 degrees and 72.8 degrees. The initial tangential velocity was 180 miles per hour. The final tangential velocity is 307 miles per hour, which gives us an acceleration rate of 0.015 meters per second, very small. So the plane would have to accelerate at 0.015 meters per second to match the new tangential velocity of the ground after an hour. Again, at 72.8 degrees latitude, the tangential velocity is 307 miles per hour. 72.8 degrees minus the 7.2 degrees travelled per hour by the plane means that it would be at a 65.6 degree latitude. The 65.6 degree latitude tangential velocity is 429 miles per hour. Tangential velocity difference of 122 miles per hour, giving an acceleration rate of 0.015 meters per second that the plane would need to gain in order to match the new tangential velocity of the ground that it's now moving over. 65.6 degree tangential velocity equals 429 miles per hour. So 65.6 degrees minus 7.2 degrees, again for the plane travelled in that hour, equals 58.4 degree latitude. 58.4 degrees tangential velocity is 545 miles per hour. Tangential velocity difference of 116 miles per hour, giving an acceleration needed of 0.014 meters per second. The tangential velocity at 58.4 degree latitude is 545 miles per hour. 58.4 degrees minus 7.2 degrees equals 51.2 degrees. At 51.2 degrees latitude, the tangential velocity is 651 miles per hour. The tangential velocity difference is 106 miles per hour. The acceleration rate needed is 0.013 meters per second. The tangential velocity at 51.2 degrees is 651 miles per hour. 51.2 degrees minus 7.2 degrees equals 44 degrees latitude. The 44 degree latitude tangential velocity is 748 miles per hour. Tangential velocity difference of 97 miles per hour. So to sum that up, a plane travelling from 72.8 degrees latitude to 65.6 degrees latitude needs an acceleration rate of 0.015 meters per second, very small. From 65.6 degrees latitude to 58.4 degrees latitude needs an acceleration of 0.014 meters per second. From 58.4 degrees to 51.2 degrees latitude, the plane needs an acceleration of 0.013 meters per second. From 51.2 to 44 degree latitude, the plane needs an acceleration rate of 0.012 meters per second. Very small acceleration rates needed. So yes, it would be possible for a plane to land. Something deep inside won't let